Good afternoon, everyone. We are Team Clean Slate, and our project is the autonomous whiteboard cleaning robot. My name is Derek Yap, and for this project, I've been in charge of critical design reports, as well as keeping track of the different activities we do so that we're on time with our project, as well as the originator for the idea of this project. One night at UTD, after filling a board with writing, I reached to go and clean the whiteboard, and I saw this magnetically attached rag. And I thought, wouldn't it be a great idea if this could be automated? Imagine a professor, after a lecture, at the press of a button, could go ahead and clean the entire board for them, while they can take that time to take questions for the students that need help, instead of wasting their time with this whiteboard. At this time, I'd like to open the floor to my teammates and allow them to introduce themselves, as well as talk about the contributions they've done for the project.
Hi, I'm Jaspreet Chawtha. I'm a computer engineer and lead programmer for the project. Right now, at this time, we're currently testing our project with gyroscope and omni wheels, and I was also in charge of ordering parts for the project. I'd like to pass it on.
I'm Andrew Slaney. I'm a double E here. I've been working with battery solutions for our device. Now, we've actually just been trying to build a prototype with the chassis and everything, so we haven't actually really been able to dive too deep into the batteries, but the main solution that we're trying to find is how can we get a lightweight design that packs the punch that we need to drive our motor. So we've actually been going into more of a lithium polymer battery state because it has that lightweight design that we desire, and we're facing the ever prevailing force of gravity. So it's been a rough one, but we're gonna get through it one step at a time.
My name is Omer Lukmani. I'm an EE. My main goal this semester was to work on the chassis design. You'll see kind of a prototype variation that we made for it, but since the slide was put up, we've made quite a few updates, something that's a little more realistic. One thing that we've had a challenge with so far is trying to find the right strength for the chassis, but at the same time keeping it light. We don't want it to keep too heavy because it'll go back to what the issue is. We don't want to fight gravity as much. So.
My name is Francisco Delgado. I'm a double E over here. I'm the team leader, so I've been kind of keeping everybody on task, making sure we have the right goals and communicate with Dr. Taka. So the way this thing's going to work is, right now it's meant to basically go on any size magnetic whiteboard. You can just kind of stick it on the board, push a button, and it'll align itself and kind of do, if you look over here, a scan line pattern where it'll clean one lane, come down, clean another lane. And it'll do that until it gets to the bottom of the board using sensors to detect the edges and make sure that it stays on track, using the gyroscope to stay level and making sure the omni wheels are there. One, they look cool, and two, to keep it without having to turn as it goes from lane to lane. Currently, we have a prototype that will stick to the board that has a clearance of about 2 millimeters that we're going to allow for felt. Our initial idea is to use the felt to clean the board and see how well that does on a first pass through, and then if we need to introduce other things such as a liquid solution, we'll go from there. But right now we'd like to open up the floor for any questions.
Have you thought about a way to change the felt that you use and clean the board easily? Because obviously it's going to.
So one of the ideas we've tossed around was kind of like a Swiffer Velcro pad. You can just stick to the bottom of the board, and as it cleans, if you need to change out the pad, we can just kind of Velcro it back on there. Right now we're going with just, we bought some felt from Joann's. We're kind of just super gluing it on there and seeing how well that does. Seeing how many different thicknesses we need to get the felt, and seeing how much force we need with the magnets to actually get the felt cleaning. Yes.
Any safeguard on the fact that it may accidentally start in a race before it's supposed to?
Yeah, so we're gonna have a user input button on there that, so once you stick it on the board, you have to actually push a button and then it'll start on there on its own.
So the replacement for this is a 50 cents eraser.
Yes.
Create something that costs $10, it's never going to fly.
Yeah.
So have you thought anything about the economics of what the price point it needs to be? Because you can create the most elegant solution, but
Yeah.
never fly in the real world.
Right.
So I'm wondering what have you thought about that?
So we haven't quite looked into the economics of it yet. Right now, most of our view is on the convenience of it, of just having something you can put on the board and do as you're getting ready for your next lecture and things like that. And then economically, it hasn't been that much. We bought a 3D printer just to rapidly prototype, and the printer plastic itself, I think the chassis we have right now weighs about 100 grams, and the 1 kilogram roll of plastic we bought was $15. So the motors themselves are the most expensive part of this, but we probably will look into the economics of it on our second semester.
You guys have some kind of a safety rope on it or something, so if it does drop, that you don't lose the whole thing. It just
We don't have anything yet, but that's a great idea. I like that idea. Maybe just like attach something to the
Yeah.
pendulum. Thank you for
How
that
about a
idea.
cake down whiteboard?
Hmm?
Like this, there's writing on it for days and the professor kind of erases over it, so it's got layers of stuff on it. Have you thought about that scenario?
We have thought of that scenario. For right now, we're working on just the first pass solution, but we're looking into maybe a liquid reservoir solution. Maybe we can spray something as it passes through, because we know that the Windex will do a little bit better, but we got to worry about slipping or skidding with the wheels as well. But that's something we're looking into right now. Any other questions?
For your performance metric of 20 to 30 minutes per cleaning,
So that one is based on a classroom-sized whiteboard, so something that would be maybe 30 feet by 8 feet long. Something that we kind of use that metric as there's a 15-minute time period between extra classes, so we're thinking, professor can stick it on the board, push a button, and then by the time the next professor is ready, settled into his class, the whole board will be cleaned.
and then your battery life is four cleanings.
Yeah, so we're hoping the battery life will be something that 4 or 5 cleanings that we can just put it on a charging station and then have it ready to go.
All right, let's thank the team.
Thanks, guys.